Hello everyone. After learning the object-oriented programming and exception handling, now we are starting with C# advanced features. The object-oriented programming and the exception handling is available in almost all OOP languages, and conceptually, even syntactically, they are quite similar. So far, we have created the basic syntactical baseline to learn the real .NET features. In my understanding, these important .NET features is about collections, file IO, reflection, attributes, multi-threading, lin queue, and database connectivity. We are going to focus on all these features in upcoming videos. But out of all these, the most important stuff is collections. Before we get into the collections, some core concepts need to be very clear. These collection basics primarily talk about the indexers and enumerators. We also talk about id return keyword, and that is basically the topic of the today's class. We will also talk about some miscellaneous concept like expression-bodied members and target type constructor. So let us get started with one collection implementation. Here I have already created one new solution, and inside that I have created a simple console application, and we have implemented the basic hello world. Now I want to create a new collection. Let's take very easy collection like a stack collection. I'm sure everyone is aware of the stack. So stack is basically a simple collection that provides me last in, first out kind of behavior, where you want to put the elements one on the top of other, and whenever you add the element, it is always added from the top. Wherever you are removing the element, you are always removing from the top. This basic implementation logic is same in all programming languages. So let us try to implement a simple stack of strings in the C#. Let me create a class. I call it as a stack class. As I want to keep multiple elements into the stack, let me declare the array of strings, and I call it as a items array. I do not want to hard code the length over here. But next, I want to have the topmost index. Let me mention the topmost index. And traditionally, when we are implementing a stack, the topmost index start with -1. I'm using field initializer directly to initialize it. Purposefully, I have not used new keyword over here to fix it because I want to pass number of elements into the constructor. My next step is to write the constructor, a parameterized constructor where we will pass the capacity of the stack. So let me write the constructor. We can pass the size, and based on that, we will initialize the items to that size array. Now we can also write the additional functionality, like we want to write a property for the top, but I do not want to modify it from externally. So I just want to declare it as the read-only property, public int top, and read-only property get, which is returning the value of top. We can also implement the total number of elements present, and total number of elements will be whatever is the top value, that plus 1. Initially the top is -1, so -1 plus 1 is 0. So initially my stack is empty. So we have count, and we can return underscore top plus 1. Going ahead, I want to implement the basic operations like push, pop, pick, and to check whether the stack is empty or not. For that, let me write the method push, where we can add the string item. Now, to add the element into the stack, the basic logic is nothing but increment the top and then add the element. Initially, the top is equal to -1. So first element will be added. After doing plus plus top, it will become 0, and 0th position, the first element is added. If someone call the push once again, then the top will be incremented from 0 to 1, and the element is added into next position. And this will keep happening one after another. Then I want to write the pop function. In the pop function, I want to return the topmost element, and not only return the topmost element, but also I want to take the top to the previous position, which was done again as a single liner underscore items of top, and we have also done top minus minus. We can also have the function like a pick function, and pick function does similar job, returns the topmost element, but it doesn't delete the element, means my top is not modified. So I will simply remove the minus minus from here. Also, I want to check whether the stack is empty or not. You know that stack is empty at the initial position where the top is equal to -1. So let me write another method which will return me a boolean. Public boolean is empty. Here we can think of writing it as a property, or we can think of writing it as a function, as of your choice. So when top is equal to -1, my stack is considered empty. If it is condition true, I'm returning true. If the condition is false, this will return false. Let me check if this stack is providing me last in first out behavior. For sake of simplicity, I have avoided the exception handling, the validation checks. Let me create the object of the stack. And in this case, let me create the stack of 5 elements. Now I can push certain values into the stack. Let's say I have pushed A, B, and we can push probably few more elements like C, D, E. Since it is a stack of only 5 elements, maximum 5 elements can be pushed. Afterwards, it may throw me index out of range exception. Now, if I want to pop the elements one by one, how I can go with this? While stack is not empty, we can pop the elements one by one, and then we can print them. So I can simply write console.writeLine, and I say popped item is equal to this. Let us try to run this and check. Since elements are pushed in order A, B, C, D, E, I want the answer in reverse order like E, D, C, B, A. Let us check it if it is working well. Yes, this is working very well. So this tells me that my basic stack functionality is going good. However, now I want to talk about the first topic of the today's class, and that topic is nothing but expression-bodied members. In this expression-bodied members, I want to tell you that whatever big code that we have written, for every method we have written 1 or 2 lines of code. Is there any possibility that we can reduce the code and try to make it more readable? This is nothing but more of syntactical feature provided into C#. And this is a shorthand for writing a single line of code, writing a single expression. I can use it for methods, constructors, properties, or destructors, or you call it as finalizers. Here is one very basic level example. Typically, when we write a square method, we write a curly bracket and we write a single statement like return x into x. But if it is going to be the single statement, instead of putting curly bracket and writing code inside that, I can use it like one expression. And that expression is given using this arrow operator like your lambda. So I can simply declare the method, and then it implicitly return the value x into x. Please note that there is no return keyword required over here, just like your lambda expressions. And then there is another example showing me how we can write the property. So consider a bill class, and I can write the property. Again, for the property, we usually write the get, we write the set, then we write the curly brackets, and inside curly bracket, we start writing a code. Again, if you want to write the multiple lines of code inside getter and setter, curly brackets are required. But if you just want to return the amount, a single line, that is enough with this arrow operator. And then again setting, if you want to set only a single value without any kind of check, then I can simply use the arrow operator and I can set the value. I hope you remember that in properties, value is a keyword. Further, if I want to write a read-only property, the property which doesn't have any setter part, then this can be further shorthand. Like you can see the tags over here, where I'm directly writing underscore amount into 5%. In this particular case, if I have not mentioned even get and set keyword, by default, it is considered as get. So it is a read-only property where we are only reading the value, we are not modifying the value. So this particular syntax basically makes your code readable for the single liner. You need not to write the curly brackets and put like single line of code into that. And this typically encourages functional style coding, exactly similar coding that we had written with the lambda expressions. Now, this is a basic syntax. How exactly we can put it into our stack class? Let me go back and modify the stack class using this expression-bodied members. I will start with the first constructor itself. Again, you see that there is a single line of code to be written over here. So I will avoid putting these curly brackets. I will use this arrow operator, and then that single line of code, I'll put it over here. Going ahead, I want to write the top. Again, on the similar way, we can write it get, and only the getter part that I have implemented over here. But I told you that if you want to implement only the getter part, you can make it more simple just by putting the top plus 1 over here. There is no need to rewrite the get or curly bracket even for that. So this could be even easier way of writing the read-only property. Again, you see that my push method is also having a single line of code, which again I can implement it over here. Let me remove the curly brackets. Same logic goes with the pop. Please note that there is no need of return keyword because this is already the expression. So the value is implicitly returned from here. Same logic for the pick. Even same logic goes for isEmpty method. Now you see that the big stack class is reduced to such a small code. This is possible due to the expression-bodied members. Now that you have understood the stack class, we can go ahead and explore the next feature. The next feature I want to talk about is an indexer. What is basically the indexer? We discussed about operator overloading, and you remember that the operator overloading is used to make the code more readable by using the operators with the objects of the user-defined classes. But over there, we've seen that we cannot overload certain operators. We can only go with the some basic operators like arithmetic operator and the relational operator. But what if I want these stack elements to be accessed directly inside the main, and I want to access it with the syntax s of I? Now, don't you think that this shows me kind of the index operator or subscript operator overloading? However, overloading subscript operator is not allowed in C#. But what you can do over here, in order to treat my object like an array, we can implement something called as an indexer, where whatever thing we are writing over here, it will internally call the getter or setter part of the indexer. In that sense, the indexer looks like a property. Let me tell you what exactly I'm talking about. So, indexer allows object to be used as an array like this subscript operator. And then if you want, you can use it on the left hand side of the assignment operator or right hand side of the assignment operator. The typical syntax followed by the indexer is you need to write the method in which the name of the method must be this. It is a hard-coded name. And then you need to take the index. Usually we use the integer index. However, you may choose the other index type like string. And then we can have the getter and setter part. Like the getter part will be useful when we are using it on the right hand side of the assignment operator. And setter part like properties, it will be useful when we are using it on the left hand side of the assignment operator. Please note that the indexer function name must be this. So this is indirect way of overloading index operator in C#. So let me try this. How exactly we can implement it? Though I can implement indexer as the single liner, I will prefer to write the proper indexer, and we will also do the index validation in it. So let us go with the indexer syntax. Now we know that in our case, it is a collection of strings. So I will return the string. Then I told you the method is this. And then I'm using the integer index. Now there can be the getter part as well as setter part. So we will write the getter part and we will write the setter part separately. Inside getter part, what all I want to do is to return the value at the given index. So the code is like only one liner where I'm returning items of index. But it will be really good if we can check whether the index is valid or not. So I can have a check if index is less than 0 or index is greater than top. In that case, I would prefer to throw the exception like index out of range exception. And something similar, we can do it for the setter as well. In case of setter, I want to set the value. Yes, the same value keyword like properties is available over here. So that value, I want to assign it into the items of index. And again, we can have the similar error check, similar index validation over here. That's it. Your indexer is ready. Now you can access the index element directly. Let me check. Let us try to print the element at the second index. How we can do that? Let's say S of 2 is equal to S of 2. Let me run this and you cross check that the second element is going to be C. If you wish to modify that, you can actually modify the second element. Instead of C, let's say I'm writing it cat. And then let me run it once again, where you see that earlier it was C, but then it is modified to the cat. What exactly happened? How exactly it is executed? Let me quickly debug this. And for debugging, I'll prefer to put the breakpoint in a getter as well as setter. Let me start debugging by F10. This is a place where we are trying to call the S of 2 getter part to get the value at that element. Now you will find that it jumped to the get part and then index is validated, which was second index, which is valid index. And that is the reason we are returning items of index, which was basically C. That C is returned and printed on the console. You already seen that output. And then let me try to modify this. Now while modifying, it will internally make a call to the setter, and then again index is validated. The value C is now replaced with cat, and you can see the update into the output. Let me just say F5, where you can see the actual output. That's great. So you understood how this indexer is working, but how this indexer is working behind the scene. What sort of logic or what kind of code is generated behind the scene? Let me tell you, whenever we are writing this indexer code, it is just one syntactic sugar. It is only simplification of the code. Whenever we are writing the getter part, it will internally generate a method called as a get underscore item, which will take the index and return the given value. On the similar way, whenever we are writing the set, the compiler will internally write set underscore item, and then for that index, the value, given value will be set. This is exactly how the indexer works internally. If you want, you can verify this using IEnumerator. Let me just do one thing. Let me open IEnumerator for you. So let me go to the developer PowerShell, and in developer PowerShell, I want to see this particular application. So let me jump to that directory. Let me get into the directory bin and then debug and then .NET 10.0. This is where actual my DLL is created. Now I can use IEnumerator and let me give this DLL name. Now you can check that we had written this stack class, and inside stack class, do you see the method get item and set item? This is internally written by the compiler when we are writing indexer. I hope this clears how indexer exactly works. But one thing is sure, indexer makes your code readable. You can treat your object just like an array. You can get the value as well as you can set the value. Now, let me talk about one very small and straightforward topic. And that topic is nothing but target type constructor. Now, while creating an object, every time we follow the full syntax, like class name, then we use like an object name is equal to new class name. And this class name is redundant, especially when the class name is big enough. At that time, it is very complicated that you are typing all that thing once again. This is where C# brought the new feature called as target type constructor, which helps me to create the object without using the class name once again. And you can write the code in a simple manner, just removing the class name once again. That's it. This is nothing but target type new syntax. This is exactly again a syntactic sugar. This will internally get converted into the new stack. But this many times simplifies your code. As I said, especially when the class names are bigger or you are going with the generics and there is a complex generics declaration inside it. Now that we talked about these three concepts, let us move on to the next important concept. Very important concept called as an enumerator. As we are going to talk about the collections. Now collection items will be accessed one by one. And many times you use the for each loop to access the elements one by one. But you ever bothered about how this for each loop internally works? This particular thing you will understand if you understood enumeration very well. So enumeration is a process. Enumeration is a way that you can traverse the collection. you can access the elements one by one. And if you want to do that, there must be a standard, there must be a specification. That specification is nothing but IEnumerator interface. This IEnumerator interface has got three members. The first one is MoveNext method, which returns Boolean. The job of this enumerator is to keep the track of the current element and then keep advancing to the next element for every next iteration. So MoveNext will actually take you to the next element in the collection. And then we can access that element using the property that is nothing but current property. So if you want to write your own enumerator, you need to implement the MoveNext method as well as current method. Apart from this, it also provides one method called as a reset. The reset method will reinitialize enumerator to its initial position. And in .NET, it is a common convention that enumerator always starts before the first element, so that when the MoveNext is called for first time, it will actually go to the first element, and then that first element will be accessed using current. The most common way of using IEnumerator looks like this. Let us consider that you have any collection by the name, let's say C. So if you want to access the enumerator, you usually use collection.sum method, which will return me the enumerator, like get enumerator. And then I want to access it one by one, because this initial enumerator is keeping me at the position before the first element. I need to first take it to the first element, like while en.MoveNext. MoveNext will take it to the first element. If the first element is available, then it will return me true. And then I can get the current element. You can access the current element just by saying en.current, which is a property. Now you can print that particular element, or you can perform certain operations on that element as per your requirement, and then the loop repeats. In the next repetition, it will again go to the next element, and again the current will access the current element. This will keep happening again and again until end of collection is reached. Moment we reach to the end of the collection, it will return me the false value. So this is a way we can use it again and again. Now let us talk about how exactly we can write the enumerator for my stack class. You know that my stack is internally having one items. This is an array of elements. For time being, we have set it to the 5 elements. Now, by default, I want the enumerator should be keeping track, and it should be initially pointing to the before first position, like -1 in this case, because the first element will be 0, 1, 2, 3, and so on and so forth. By the way, for my stack, logically, my last element should be the topmost element. So topmost element where the last element is inserted. Let us consider that currently my stack has got A, B, C, and D only. So my enumerator should be able to access only these 4 elements. Well, how I can deal with this enumerator? So that can be written something like your own class. You can give any name to the enumerator as of your choice. I can give it, let's say, stack enumerator. As I said, the standard process to implement the enumerator is to inherit it from IEnumerator. Now, inside this IEnumerator, I want to keep the track of the current position. And we need to also probably keep a track of the collection that we are traversing. So typically, the data members that you will need is the stack, and Another data member that I can use for this stack is the current position. As I said, we can have a constructor, and inside constructor, our initial position will be kind of -1. So we can simply write the code like constructor, which is taking the stack and initializing the stack, and the initial position is equal to -1. That's good. Now I want to implement the actual method like MoveNext and current, which are the most important methods. So MoveNext will take me to the next position if possible and return true. If not possible, it will return me false. So let me implement the method bool MoveNext, where I need to check whether I can go to the next position. So as long as my current position is before top, I can definitely go to the next position. So position is less than top, then incrementing the current position is feasible. So I can write it underscore position plus plus. And since it was successful, I will return true. However, if I have already reached to the end of stack, in that particular case, I need to use return false. Of course, I need to close the curly bracket. Now, this position is keeping track that exactly which element is currently getting access. So if the position is over here, then I want to return the current element as like B. How we can return that? As I said that we have another property called as a current. So I can implement on the property current, the return type is object, so that it can work with any collection. And then current, it is a property. If it is a property, you can go with the single liner syntax, or we can write the proper get, and we can say return items of position. Now the only method left which is not commonly used is like a reset method. And in reset method, once again, I want to set the enumerator back to its original position, that is nothing but -1. I hope this gives you clarity how enumerator internally works and how we are going to write the code of enumerator. It is very common practice to write the enumerator as the nested class or inner class of the collection class, so that it will have direct access to the private members of that particular collection class. Let us do exactly same in our case as well. So let me just go back to the stack class, and inside this, let me write the class called as a stack enumerator, inherited from IEnumerator. Inside this, as I said, I will have the basic data members like stack, and I want to also keep the current position. Now, inside the constructor, I want to initialize the stack, and I want to keep the position is equal to -1. Then I want to actually implement all these three methods one by one. The first method that I'm talking about is MoveNext. And inside this method, I want to check whether it is possible to take it to the next position or not. And I will do it by checking if position is less than the top, the number of elements actually present into the stack. Then I want to increment position, and since increment is possible, I said return true. However, if it is not less than top, means we already reach to the end of the collection, so we can simply say return false. By the way, this top is the private member of the stack. Not to worry, since we are in an inner class, I should have direct access to that. Now, current method, which will just return me the element at the current position. That should be very easy job. As I said, we can write it as a single liner over here. And then we also have reset method, which will reset it to the position -1, that is before the first element. Yes, so my enumerator is ready. Now this enumerator should be returned from your collection. So let me go back to my stack class, and inside stack class, let me write another method called as getEnumerator. And inside this, I want to write a single line of code, which is simply creating the object of stack enumerator. But this stack enumerator needs the reference of the current stack to which it is enumerating, to which it is traversing. That is the reason we have passed this. This means the current stack object. Let us check whether this works well or not. So let me go ahead and let me comment this popping code for time being. And instead of popping code, let me do the traversal. Let us first create IEnumerator object, like IEnumerator E is equal to getEnumerator. And while you are able to go to the next element, you can access the element one by one using the current. That's it. Nothing much is needed. Please note that here we are traversing from -1, means 0th element, to the last element. So this will go in order A, B, C, D, E. Currently 5 elements are present. You can check that. Is it printing all the elements exactly in the same order? Yes. If you want to understand, you can quickly debug it. So let me just say F10, and here we are creating the enumerator object. And in this enumerator object, the initial position is equal to -1, and it is pointing to the actual stack. Now let me say F11, where it is ensuring that it is before the last element and position is incremented from -1 to 0, and then it returned true. Now currently position value is 0, which you can verify over here. Now when I access the current, let me check that. To access the current, it will give me the element like A, and this will continue till the next element again and again. After completing all 5 elements, it will return me false and it will come out of the loop. This is how the enumerators work internally. It is very easy to use for each loop all the time, but many times people do not understand how exactly the for each loop works internally. So in my opinion, it is worth putting in efforts once in the lifetime to write your own enumerator and understand how the things are working, how the traversal of any collection is happening behind the scene. Well, I told you that this is what exactly happens behind the scene when we go for each loop. Yes, it is true. So question is, can I actually use for each loop with the my stack so that I will be able to traverse the element once again? Let us give a try. Let's say for each, let us access each item in the stack, and then I want to print these items one by one. So let me just simply try to print the item one by one. So let us try to run this and check if it is working well. Let me run this, and you find that this is providing me exactly same result. Do you know why it worked in exactly same way? Because the method name that we have used to create the enumerator, getEnumerator, is a very standard method name. And this standard method name is provided by one interface. That interface is called as IEnumerable interface. In modern C#, by default, if the method name is getEnumerator, it internally considers that the class might be inherited from IEnumerable, and it calls the method getEnumerator behind the scene. But the standard way to write this method is actually to make your class inherited from IEnumerable. So this IEnumerable has got only one method, and that method is named as like getEnumerator. Please make a note, the for each loop internally use IEnumerable's getEnumerator method to get the enumerator object. That is what we done in our code. And then it traverses the actual collection using the enumerators MoveNext and current one by one. If you want, you can put in breakpoint into the getEnumerator, MoveNext and current, and you can go with the for each loop once again. Let us debug by saying F10. Now where the for each is called, you will see that it will internally make a call to the getEnumerator, and that will return the actual enumerator object. And then it will internally call the MoveNext, which will ensure that the next element is available, and then it will call the current property, which will return the first element that is printed. And then it will again call MoveNext to go to the second element, and then current property to access the second element, and then again print it. This will happen repeatedly to access the elements one by one. When all elements are finished, then the MoveNext method will return false, and then the iteration will stop. I hope this gives you the clear idea how for each loop internally works. Well, now that you have understood how to write the enumerator, how for each loop internally works, I think now I can tell you a shortcut of C#. This can be little complicated for the first time developer to understand the enumerator and all that. And that is the reason in .NET we have got a keyword called as yield return. Let me first explain you what is yield return, how it works, and then we will try to implement it in our stack class. Let me show you first the basic concept. Let me comment this code and let me write a new main. And here I want to write a very simple example of yield return. Let's say I have a method which is returning IEnumerable. Let's say I want to say get numbers, and I want to return three numbers. Let's say the first number over here is 1, the second number is 2, and third number is 3. Now you people understand it very well. In normal C# code, when I say return, the control returns from here, and next statement is never executed. So what exactly yield return do for me? Yield return internally perform some magic so that it will return me the first value, but it will retain the last state, so that the next iteration it will start from the next statement after the yield return, and then it can return me the next statement, and then it can return me the next statement. Let me show you how this will work. So let me give a try on a simple for each loop. So for each loop, for each number in get numbers, and then I want to simply say console.writeLine, and I want to print that number over here. Let me build my code once again and run it. There you see that the output is 1, 2, 3. By the way, how exactly it executed, you can understand it better by debugging it. Let me try to say F10. Now, when I'm accessing the enumerator over here, you will find that it is going to my method, executing the first statement. It is saying yield return, which is returning the first element. So num is equal to 1. It is printed, but in the next iteration, it will continue where it stopped last time. So the next time it will go to the next line, and then it will return 2, and that 2 will be printed. Again, now you will find that it will go for yield return 3, and 3 is fetch, 3 is printed, and then it will try to go to that method once again, where it actually say that the end of the method is reached, means the collection is exhausted, and that is the reason it will come out of the loop. I hope this gave you little idea how return can be used to return multiple values from the function. And exactly this logic, we can use it for writing one enumeration for my stack class. Let me now go to my stack class and try to implement it. Again, I'm going to my original main, and at this time, I do not want to write the get enumerator in this way, which is a standard enumerator method. I do not want to implement that. Instead, I will write it using the return keyword. How? Let us write it like public IEnumerator. I'll keep the method name as getEnumerator so that it is following the contract of IEnumerable. And then inside this, instead of creating a stack enumerator, I will use a simple loop to access all my stack values, like for integer I is equal to 0, and then I is less than or equal to top. We are accessing the elements one by one with I++. The normal way we can try to return the items of I. But again, this is a normal return, which is returning only once. What I said, I want to keep the last state, and then I want to continue accessing the next element each time, which can be done by using yield return. Please note that this yield return keyword is always used in combination. It is never used only yield keyword standalone. Now let me rebuild this once again, and let me try to run the same thing once again. Do you see that this is providing me exactly same output? Let us quickly try to debug it once again. While debugging, please note that we are still using the same for each loop. Now from here, when I say F11, it should be internally calling that enumerator. Please note that value of I is 0 at the moment, and it is returning me 0th element, which was A. That A is printed, and then again I'm saying F11, where it is now continuing on I++, making it equal to 1, and then condition is true. I'm returning the first element, that was B, and that B is then printed. Something similar, it will go on to the next element, return the third element, cat. That cat is printed. The next element, D is printed. The next element, E is printed. And finally, when it will go back, it will find that the condition is false. It will come out of the loop, and then getEnumerator method is giving a signal that no further element is available, kind of internally returning a false. And then it will come out of the for each loop, and my code execution stops here. I hope you understood that this could be very easy way of writing the enumerator. Now people ask the question, if I could do it in such a simple way, why we learn all this enumerator and all that kind of stuff? Let me tell you very clearly that this is again a simplified syntax of writing the enumerator. If you really want to understand how exactly this yield return works internally, then I will take you back to the iodism. Let us open that iodism once again, and this iodism will show you that inside the stack class, when we have written that yield return keyword, it has internally created one enumerator on its own. This stack enumerator was implemented by us, but there is a get enumerator. This was implemented due to that yield return statement, and you will see that inside that again that MoveNext function, or inside that again the current and all reset, all these methods are already implemented, which is again internally using the similar logic like that, keeping the current state and everything. So if you really want to understand this, it is a better idea that you first learn to write your own enumerator. That is what exactly I try to show you. So we first written our own enumerator, understood how enumerators will work, and after that understanding, we look the simplified syntax using ill-written keyword. Now you can write the code in a simple way. At the same time, you also understand what is happening behind the scene. Now, when we start with the collection, I'm very sure that you will have more clarity on how exactly the for each loop works behind the scene. So, in this particular session, we talked about the expression-bodied members. Then we talked about the indexer. We discussed the target type constructor. We talked about the enumerator actual implementation, and we talked about the ill-written keyword also. Now, before we get started with the collection, very important thing that you should be knowing is nothing but generic programming. So in the next class, we'll talk about generics, and then we can jump into the actual C# collection. I hope you find this session very useful. Thank you very much for listening patiently. See you in the next session. Bye bye.